Hello, St. John's 7th graders for the 2020-2021 school year. This is the second of 3 installments of your summer videos and a small amount of work to go along with each one. I'll be posting this video in the Google Classroom along with a paper to do some problems that this video will help you with. And it's all review. We've done all of this already. The subject is percent problems. And there are at least 3 types of percent problems that I'd like to mention, sort of give you a roadmap of where we've been and where we're heading. These 3 types of problems are not the only things that you can do with percents, but it's part of it. We're going to begin with this, the definition. Mathematics always begins with definitions and basic assumptions that we then build the whole structure on. X% is X over 100. That's it. It's very simple. The X can be literally any number. It can be 0. It can be a whole number. It can be negative. It can be a fraction. The X can be anything. X% is simply X over 100. The word of means multiply. The word is, or any form of the word to be, the verb to be, is equals. Also, I didn't write it here, but when we have an unknown number, we assign a letter to it. So here's the beginning. Now, let's look at a very straightforward situation. We have the true statement here that 15 is equal to 75% of 20. And the reason that we have 3 types of percent problems is that this is a relationship with 3 numbers. The 15 is 75% times the 20. Notice the word of, meaning times. And we can have 3 types of percent questions because any one of these 3 numbers could be unknown. The easiest, and what I like to call type 1 problem, is if the 15 is unknown. And then the problem might be stated like this: what is 75% of 20? And you might want to write that as an equation, x equals 75% of 20, but the x is already by itself. That's why this is easy. If the 15 is unknown, you simply have to multiply these 2 numbers together to find x. The second type of percent problem, what I like to call type 2, is when the 20 is unknown. And that type of problem would then be worded like this: 15 is 75% of what number? And we're actually going to do some like this. We're going to do the type 1 problems and the type 2 problems. The third type of problem is when the percent is unknown. And a problem like that would be worded like this: 15 is what percent of 20? Now, in the 6th grade course, the 6th grade textbook, type 1 and type 2 are there, and we covered them. When we get to the 7th grade textbook and the 7th grade course, we will review type 1 and type 2, which we're doing now. So you should, by the end of going through this video and the worksheet with it, you should be a master of type 1 and type 2. When we get to the chapter on percent problems, there'll be a type 3, which will be finding the missing percent. You can't, like I sometimes say to my students, you can't do everything at once. Textbook authors and teachers have to draw lines as to what we do now, what we do later. But I don't want you to think that this third type that's going to be new to 7th grade is very difficult. It isn't. It's just that, like I said, we have to draw the line somewhere. So let's we will look at a series of what I call type 1 questions, where this number here, the 15, is unknown. And the first one we'll do is this exact one. What is, if the 15 is unknown, what is 75% of 20? So we can write that out like this: what is 75% of 20? And if we go left to right and translate that question into more math symbols, the missing number, the what, is the x, is equals, and I've converted the 75% to 75 hundredths, which it is. Of is times, the raised dot is times 20 over 1. 20 is 20 over 1. We multiply across the top and bottom. 75 times 20 is 1,500. 100 times 1 is 100. 1,500 divided by 100. 1,500 over 100, of course, is 15. You got the two zeros there, the two digits to the right of the decimal point, 15.00, or just 15. Now, you may recognize that 75%, as a fraction, it is 75 hundredths, but it simplifies to 3/4. 75% is another name for 3/4. So you might want to translate this into what is 3/4 of 20? And you can do that two different ways, at least. You could do 3/4 times 20 over 1 and get 60 over 4. 60 divided by 4 is 15. Or you can think of it this way. 3/4 is 3 times a fourth. So you can think of 3/4 of 20 as 3 times 1/4 of 20, which I wrote over here. 3 times 1/4 is the 3/4. And then we can do the 1/4 of 20 first to get 5. And 3 times 5 is 15. So there are a couple of different ways to answer the question, what is 75% of 20? The next thing I'd like to look at is just to give you a sense of percents that are either 100%, less than 100%, or more than 100%. This understanding this sort of dividing line here, I think, is important. I've chosen the number 800, and I'm asking a series of questions. What is 1% of 800? What is 50% of 800? And so on. Let's look at that one in the middle. What is 100% of 800? Now, that's easy. It's obvious. It's 800. 100% of any number is the number. Now, why is that? Well, 100%, recall, is 100 over 100. 100 over 100 is 1. So 100% of 800 is 1 times 800, which is 800. So let me write the answer in there. 800. Okay. Now, for these percents that are less than 100%, for the 1% and the 50%, the answer has to be less than 800, right? In the case of 1% of 800, the answer is going to be a lot less than 800 because 1% of something is only a small piece of it. Now, some of you might have the number sense right now to realize that 1% of 800 is 8, which is a very small portion of the 800. I'm not going to write out the work to that. If you need to, go ahead. But just think about it. 1% is 1/100th. What is 1/100th of 800? Well, that's 8. Again, work it out if you need to. Now, the next one is very simple. I bet a lot of you know immediately what 50% of 800 is. 50% is 50 over 100, which simplifies to 1/2. So asking what 50% of a number is the same as asking what is 1/2 of the number. And 1/2 of 800 is 400. You could have gone through and done this a long way, but the answer is 400. And now, I hope I've convinced you thus far, as your teacher, that the distributive property is very important, very powerful. When you look at this next one, 101% of 800, the first thing that should occur to you is it's going to be a little more than 800, right? Only a little more than 800 because 101% is only a little more than 100%. But if you look at two previous answers up here, we know that 100% of 800 is 800 and 1% of 800 is 8. Through the distributive property, I'm not going to write it out, but 101% of a number is 100% of the number plus 1% of the number. You can break up that 101% like that and use the distributive property. And when you add the 800 and the 8, you get 808. So 101% of 800 is 808. And it satisfies the reasonable test. We knew that the answer had to be a little bit more than 800, and it is. 150% of 800. Some of you may know this one right away. You may know that it's 1200. 1,200. Again, the distributive property. We know that 50% of 800 is 400. So 150% of 800 can be thought of as 100% of 800 plus 50% of 800. That's the distributive property, breaking that 150% into two parts. So it's 800 plus 400, or 1,200. And again, you could have done this the long way if you had to. I just wanted to give you a little taste of number sense as it applies to this type 1% problem. What is a certain percent of a number? Very often, you can either answer the question mentally or come up with a good estimation of the answer. So there's that. Now, the purpose of this next sheet is to illustrate a very important point. Many students through the years have gone down the wrong path because they forget that the word of means multiply. Please recall that. When we're doing these type 1 problems, what is a certain percent of a number? It's a multiplication because of that word of. 50% of 800 is 50% times 800. Okay? Now let's consider this question. What is 25% of 12? Now, many of you can probably do this mentally through what we might call a shortcut. It's not a lazy shortcut, it's a smart shortcut. Some of you may realize that to find 25% of 12, you can simply do 12 divided by 4 and get the answer of 3. Now, think about it. Something for a moment. I just got done saying that these percent problems involve multiplication. The word of is multiplication. But I just said there's a division. Let's see why. And if you're going to use division as a shortcut, make sure you're doing it properly. But again, I go back to the point. Even if you use division as a shortcut, we're still multiplying. So what is x equals 25% of 12? 25% is 25 over 100 times 12 over 1. Multiply across the top and bottom. 25 times 12 is 300. 1 times 100 is 100. So it's 300 over 100, which is, of course, 3. Now, here's where the division shortcut comes in. You probably recognize that 25% simplifies to 1/4. This 25 over 100 reduces or simplifies to 1/4. So we have 1/4 times 12 going across the top and bottom. That's 12 multiplying. That's 12 over 4. But the 12 over 4 is a division. There's where the division comes in this particular problem. It doesn't come into play in all of them. But it's still a multiplication. We still did 1/4 times 12. It just so happens that to simplify the 12/4, it's 12 divided by 4. So realize that role of division sometimes, but don't think that you're always dividing, because you're actually always multiplying in these problems. Another example, of course, the 50% of 800 we just did. 50% is a half. So to find 50% of 800, you do 800 divided by 2, but that's only because you do 1/2 times 800 to get 800 over 2, or 800 divided by 2. Now, we just saw that 25% of 12 is 3. So here's where reasonableness can come into play. As soon as you see the question, what is 23% of 12? You should realize almost immediately that the answer has to be a little less than 3, right? And so what is x equals 23 over 100? That's what 23% is, times 12 over 1. 23 times 12 is 276. Multiplying across the bottom, you get 276 over 100. And of course, you've got the 2 zeros here, so you can put a decimal point so that you have 2 digits to the right, and it's 2.76, which is a little less than 3. It's reasonable. So there you go. Now, you see how I wrote out 23 over 100 times 12 over 1? Sometimes I call that the long way. If I were just like, if I had to figure out 23% of 12 without a calculator, and I had to do it as quickly as possible, I probably wouldn't write it out like that. I would write it out like this. I would convert the 23 hundredths to a decimal, okay? So 23% is 23 over 100. As a decimal, that's 0.23 times the 12. How do you multiply with decimal numbers like that? Well, you pretend you're multiplying two whole numbers. You do 23 times 12. I kind of ran out of room here. But when I did the 23 times 12 as two whole numbers, I got 276. But then, of course, I look at the 0.23 and I see two digits to the right of the decimal point. And so in my answer, I insert a decimal point so that there are two digits to the right of the decimal point. And there's the 2.76. My point is that one of the things I like about these type 1 problems is that I get to remind students to reinforce the fact of why does decimal multiplication work. The reason this decimal multiplication worked is because of the fraction multiplication. Okay, we've seen that many times before. Now, this next one, I'm intentionally trying to give you a variety of these percent problems. This time, the question is, what is 105% of 600? Immediately, we should know the answer has to be a little more than 600, right? Because 105% is a little more than 100%. The long way to do this is 105% is 105 over 100. Notice that's automatic. That goes back to the definition. X percent is X over 100. So if you're stuck, you don't know what to do, at least you know you can rewrite that 105% as 105 over 100. X equals 105 over 100 times 600. Multiplying across the top and bottom, 105 times 600 is 63,000. I almost ran out of room there, but 63,000, and 100 on the bottom, 100 times 1. And then we've got 1, 2, so 1, 2 digits to the right of the decimal point, and we get 630. And once again, rather than writing out 105 over 100, rather than writing it out exactly like this, you might look at the 105 over 100, realize it's 1.05. You know, the two zeros, two digits to the right, it becomes 1.05. So you just do the decimal multiplication, similar to what I showed you with the last one. Pretend these are two whole numbers. You'll get the 63,000 when you do the 105 times 600. Then you'll count 1, 2, and insert the decimal point. So the decimal multiplication is really the same as the fraction multiplication, but there's less writing. By the way, this one can be done mentally if you recognize that 5%, we've got 105%. Just take the 5% portion of it. That's 5 over 100, which is 1/20th, right? 1/20th. So if we break it apart, 100% of 600 plus 5% of 600, the 5% is 1/20th, so 1/20th of 600. What's that? What's 1/20th of 600? It's 30. So 600 plus 30. Another approach to that. Okay, now we come to this fact. Just as in the world of, pick any subject, sports, statistics, banking, business, not everything's a whole number. Even with our money, not everything is a whole number of dollars, right? So when we're dealing with percents, we have to be ready for the fact that there could be percents that are not whole number percents. Now, when I say whole number percent, I mean something like 3%, 97%, 100%, 105%, 300%, where the numerator, once you convert to the fraction, is a whole number. But see, this is what we might call a non-whole number percent. The question here is, what is 3.5% of 500? Well, the good news is that the definition still applies. Okay, we've got what is, that's x equals, and the next thing is 3.5%. What is that? It's 3.5 over 100. That is the definition. It will always work. 3.5 over 100 of 500 times 500 over 1. I want to suggest something before multiplying here. It is possible you could do 3.5 times 500 over 100 and then work with the decimal point at that point. But I'd like to approach it this way. This is a complex fraction, 3.5 over 100. The 3.5 is not a whole number, so when we have a non-whole number within a fraction, it's called a complex fraction. But we can always simplify those complex fractions into regular, simple fractions. And here, if we multiply the top and bottom by 10, right? 3.5 times 10 is 35, and 100 times 10 is 1,000. So 3.5 over 100 is equivalent to 35 over 1,000. Now multiplying across the top and bottom, 35 times 500 is 17,500. And of course, if the numbers are big, you'll have to do multiplications like that off to the side. I did them in advance to save time, but you would have to multiply that out on paper. And then 1,000 times 1, 1,000. And notice 3 zeros. So we need, when we write this as a decimal, we need to have 3 digits to the right of the decimal point because of the 3 zeros in the 1,000. And so we get 17.500 or simply 17.5. 17.5 is the answer. Now, at this point, I think it might be worthwhile to make this observation. When you have a percent and you want to convert it to a decimal without the percent sign, you want to remove the percent sign, what can you do? I think you know this rule. We talked about it. Move the decimal point 2 places to the left. If you want to rewrite 3.5% without the percent sign, move the decimal point 2 places to the left and remove the percent sign. And if you do that, you go 1 and then you go 1 more for 2. You got to fill in that place with a 0, and you get, of course, 35 thousandths. And again, you could have written 0.035. This is 0.035. Multiplied that by the 500 as a decimal multiplication. Okay. We're ready now to move on to the type 2. And again, we're not going to do the type 3 problem. The type 3 problem is the one where the percent is what's missing. But when we get to that point in the 7th grade course, I don't want you to think of it as difficult. It's maybe slightly more difficult than the type 2 problem, but not a great deal. So again, just to review, these percent problems, you always have one of the numbers missing. Up until now, it's been the 15 that's been missing. So we ask, what is 75% of 20? And we get 15. Then we did some others that were the same way. Now we're asking, what we're trying to find now, the 20 is going to be missing. And we'll ask the question. We'll say 15 is 75% of what number? Okay. And so there's that question. 15 is 75% of what number? Going left to right and translating that, we would have 15 equals 75%, of course. Once again, it's 75 over 100 of what number? Times, the of is times, and the what number, it's an unknown number, so we pick a letter. I chose X. Type 2 is slightly harder than type 1 because it's an algebra equation. In type 1, you start off X equals what number is. So there's no algebra, there's just multiplication. But with the type 2, you have to solve this simple one-step algebra equation. Now we can go through this a couple of different ways. Let's stick with the 75 over 100. And how would we isolate this X? How would we solve this equation for X? Wouldn't we divide each side by 75 hundredths? Divide each side by 75 hundredths. And of course, on the right side where the X is, the 75 hundredths are going to cancel, which is why we did it, right? Cancel, cancel, leaving the X by itself. So this is what X is. But that's a complex fraction. You can't leave it like that. remember a fraction is a division. So this says 15 divided by 75 hundredths. So we can simplify that by doing 15 times 100 over 75. Remember, keep, change, flip. To do 15 divided by 75 hundredths, keep the 15, flip the 75 hundredths to 100 over 75, and multiply. I might have said that little rule wrong. How does it go? Keep, change, multiply. Right? I think I said keep, change, flip. No, it's keep the first number the same, change the second number by flipping it, and then multiply. All right? And so we multiply across the top and bottom here. We get 1,500 over 75. And ladies and gentlemen, 1,500 divided by 75 is 20. You can check that for yourself if you need to. And we knew it was 20 because we're still dealing with 15 is 75% of 20. Okay? Type 2, it's a one-step algebra equation. Now, same question, 15 is 75% of what number? But you might recognize, you should recognize, 75 hundredths simplifies to 3/4. So you might want to keep the number smaller and write it as 15 equals 3/4 of x. Again, the solution would be the same. Divide each side by 3/4, with the 3/4 canceling on the right to leave the x by itself. And then we'll have to do 15 divided by 3/4. We'll do that as 15 times 4/3, right? We will keep the 15 the same. We will change the 3/4 to 4/3 and multiply and get, multiplying across now, 15 over 1 times 4/3 is 60 over 3. 60 divided by 3, which of course is 20. So once again, we get the answer we knew of 20. All right? Now, this one here was 15 is 75% of what number? Let's talk a little number sense now. Now we knew the answer was 20, but please try to follow this reasoning. The unknown number here had to be more than 15 because you're only taking 75% of that missing number to get 15. Think about it. If you're only taking 75% of the unknown number to get 15, that unknown number has to be more than 15. Make sure you understand that. I can't really say it. I can't think of a way to say it any differently, but just make sure you convince yourself. As opposed to this question here, this is 15 is 150% of what number? Now think about this for a minute. This time the mystery number has to be less than 15 because you're taking 150% of it, 150% of that mystery number to get 15. Make sure you convince yourself that that mystery number has to be less than 15. Okay? See that fundamental difference between the previous problem, it was 75%, which is less than 100%. This is more than 100%. So ask yourself that reasonableness question. 15 is 150 over 100 times x, right? Just translate it left to right. 15 equals 150 over 100 times x, the what number. Divide each side by 150 over 100 to isolate the x. There is a lot of repetition in math, ladies and gentlemen. And that's good. When you feel, hey, I'm doing the same thing all the time, that means you've learned the process. Those 150 over 100 cancel. Here we've got 15 divided by 150 over 100. That's going to be 15 over 1 times 100 over 150. We're going to flip the 150 over 100 and multiply. Multiplying across the top and bottom, we get 1,500, 15 times 100, over 1 times 150, which is 150. Now look at this cute result. I made this problem come out nicely. 1,500 over 150. 1,500 divided by 150 is 10. Now think about it. If you didn't already know the answer, isn't it obvious now? Isn't it true that 15 is 100%, I'm sorry, 150% of 10, right? This 10 is the mystery what number? If you take 150% of 10, that's 10 plus half of 10. 10 plus 5, 15, okay? Now, again, if you didn't like this, divide each side by 150 over 100, what if you recognized that the 150% is 1.5? You know, you can look here and say, oh, I've got, okay, 150 over 100, 2 zeros, put the decimal point here, 1.50. Or like I said before, you've got 150%. There's a decimal point there. We don't write it, but there's a decimal point there. If you want to remove the percent sign, move that decimal point back 2 places to the left, you got 1.50 or 1.5. So 150% is just another name for 1.5 or 1.5. So you could write it like this. This is the same problem. Divide each side by 1.5, divide by 1.5, and then here we multiply the top and bottom by 10 to do the division. Remember that, to divide by a decimal. So this is equivalent to 150 over 15, which is 10, right? I multiplied the top and bottom here by 10 to get 150 over 15, which is 10. You could actually think of this, if you want, as 15 equals 3 halves x. I'll leave it to you to finish this, but 1.5, 150% is 1.5, 1.5. It's also 3 halves, right? So you could divide each side here by 3 halves. That's another way to do it. Multiple pathways to success, ladies and gentlemen. All right. I have 4 more problems. They're in pairs, okay? I did this on purpose. And this is all still the type 2. The type 2 problem where the it's in the case of 15 is 75% of 20. It's the 20 that's unknown, that number. All right. It ends up being a one-step algebra problem. I'm going to ask the question, 8 is 2% of what number? And then I'm going to ask the question, 8 is 300% of what number? And see what I'm doing here, giving you a sense for the variety. One question with the percent less than 100. This is way less than 100%. And then another one where the percent is more than 100%. So let's take this one here. 8 is 2% of what number? Now, number sense. The number, this missing number, has to be much bigger than 8. Why? Because we're taking here only a small portion of it. 2%, think about it, 2% of some number is 8. 2% is only a very tiny portion, so the mystery number has to be much bigger than 8. That's a number sense that you need to develop. Translating into an equation here, 8 equals 2% times what number of x? Okay? Here's the repetition again. Divide each side by 2 over 100. So 2 over 100 cancels. We get 8 over 1 times 100 over 2, or 800 over 2, or 400. I'll give you a chance to look at that. I did 8 divided by 200ths by doing 8 over 1 times 100 over 2. 800 over 2, 800 divided by 2 is 400. Is that a reasonable answer? Well, yeah. We knew it had to be big. If you take, and you can check it, of course, if you take 2% of 400, like turn it back into a type 1 problem, if you find 2% of 400, that'll be 8, and you'll have checked the problem. Okay? Now, 8 is 300% of what number? Now here, the mystery number has to be less than 8. In fact, 300% is just 3. What this problem is saying is 8 is 3 times what number? So the answer has to be 1/3 of 8. Okay. I mean, there's a lot of different ways to approach this. But let's approach it first, just straightforward, left to right. 8 equals 300 over 100. 300% is 300 over 100. So 8 equals 300 over 100 times a mystery number. So we'll just put an x here. 300 over 100 times x. They're right next to each other, so it's multiplication. Now, this time I'm not going to divide each side by 300 over 100 because 300 over 100 is obviously 3. So that's why I said this equation that we wrote is equivalent to 800 equals 3x. And how do you solve that? Divide each side by 3, right? The 3's cancel, and you get x equals 8/3, or 2 2/3. That's a reasonable answer. If you multiply the 8/3 or 3 2/3, either way, multiply that by 3, you'll get 8. That's what the answer had to be. It had to be 1/3 of 8, because when you take 300% of 1/3 of 8, you get 8. Okay. 2 more. Again, in one of them, the percent will be less than 100, and another one will be greater than 100. So one question is 7.5 is 90% of what number? This 90% is less than 100. And then in the final problem, it'll be 250% more than 100%. All right, let's do a little number sense here. The answer here has to be more than 7.5. Think about it. We're only taking 90% of it. We're not taking the whole mystery number. We're taking 90% of it to get 7.5. So the mystery number has to be greater than 7.5, but not by much, right? It's got to be a little more. Think about it, a little more than 7.5. If you take 90% of a little more than 7.5, you get the 7.5. That's the kind of answer we expect. So 7.5 is 90% of x. Divide top and bottom. Now I could simplify the 90 over 100 to 9/10, but there's not much difference. Let's divide the top and bottom by 90 over 100, canceling to leave the x by itself. And now we have to do 7.5 divided by 90 over 100. That's going to be 7.5 over 1 times 100 over 90. To divide by 90 over 100, multiply by 100 over 90. 7.5 times 100, that's easy. It is 750. 750. To multiply by 100, move the decimal point 2 places to the right. 750, and 1 times 90 is 90. We can now this is an improper fraction. The 7.5 was in decimal form. We kind of have an expectation the answer will be in decimal, but you don't necessarily have to. This is not a whole number, by the way. 750 over 90, that improper fraction is not a whole number. Let's simplify it a couple of quick ways here. Isn't it 75 over 9? Divide the top and bottom by 10. 750 over 90 is 75 over 9. Now they're both obviously divisible by 3, right? So divide the top and bottom by 3 and get 25/3. Now, I'd be perfectly happy if you left the 25/3, I guess, because with all this work. But converting it to a mixed number will help us realize if it's reasonable. 25/3, you should automatically, instantly know now that that is 8 1/3. And again, even though there's kind of an expectation that we give the answer as a decimal, I'm fine with 8 1/3. If you do 25 divided by 3 and do it as a decimal, bring a decimal point after the 25, bring it straight up, bring a 0 down one at a time, you would get, of course, 8.3 repeating. That's what 8 1/3 is. So either way, that's the answer. It passes the reasonableness test because it's a little more than 7.5, which we expected. Okay? And finally, 7.5 is 250% of what number? This is our final problem. This time, we are expecting a number a lot less than 7.5, okay? Because whatever this mystery number is, when we take 250% of it, which, by the way, that's the same as multiplying it by 2.5. 250%, 250 over 100 simplifies to 2.5. So whatever this mystery number is, 2.5 times it is 7.5. So the mystery number is less than half of 7.5, right? Substantially less. All right, let's go through it the same way we've been doing it. 7.5 is 250% of what number? Translate it left to right. 7.5 is equals 250% is 250 over 100 times right next to each other, the mystery number. What number? Okay, divide each side by 250 over 100, canceling on the right, and no mystery here, 7.5 over 1 times 100 over 250. To divide 7.5 by 250 over 100, take the 7.5 and multiply it by the reciprocal. You flip the second or bottom number, right? Keep the 7.5 the same. 7.5 times 100 is 750. And the denominator is 250. Oh, look at this. Do you see what happened here? 750 over 250. How do you simplify that improper fraction? It's 3, right? 750 divided by 250 is 3. By the way, I made it work out this way. I made it work out nicely. They don't always work out nicely, but let's check and see why this 3 is the right answer. If you take 250% of 3, if you put that 3 where the what number is, right? And over here on the right, 250% of 3. 250% is 2.5, 2.5. 2.5 times 3 is 7.5. Get a true statement. So I'm thinking that the worksheet that I provide for you, I think maybe I'll put everything on one sheet and have a few type 1 problems and a few type 2 problems. And when you're done watching this video and when you are done with that worksheet that will be in the Google Classroom along with this video, you should be masters of these kinds of percent problems at this point. Will we go through them in 7th grade? Yeah, we'll probably quickly, give you a few for homework, quiz you quickly, but you should be at that level of mastery before we even get there, which is a nice feeling because there are a lot of topics, a lot of math to cover in any grade. So if we can kind of, get this one out of the way and be able to go through it quickly, it gives us time to do more interesting, challenging things. So you're seeing this in mid-July. The third and final installment of the summer work will be sometime in early August. So bye-bye until then.